Search engine testing. Not always the most exciting topic, so I thought I would throw in a Lord of the Rings kind of flavor to it and see how that changes things up a little bit. So I'm going to be talking about I'm going to talk a little bit about search engine testing, why it's important, and then sort of specific techniques that we can use. It's a little bit of an overview, right? I want to leave plenty of time for sort of questions and answers at the end. So I only have really 35 minutes, and I know I have more content than 35 minutes will give me. But we'll see what we do. I got a couple of demos and some things. So there's my Twitter handle. Love to chat with you on Twitter, email, whatever works best with you. One of the reasons I thought about this sort of Lord of the Rings metaphor for testing is that these four guys, everybody seen the movie? Make sure I got my contacts. Everybody's going to get all, yes. These four guys went on a really, really long journey, right? And it was a really challenging journey. There were ups, there were downs, there were battles. They got separated, they got back together. It was a 3-movie epic. And I don't know how many people have read the books, but I remember reading them and thinking they were very formative. They were up there on my top, definitely on my top 10 list of books. So I will say I don't remember the hobbits looking quite so badass in the movie as they do in this promotional picture. I remember them being much nice, cheerful guys, not the badass-looking hobbits here. But yeah, I thought that they were a good representative. So who am I? Eric Pugh. I'm a principal of Open Source Connections. We are a US-based solar Lucene consultancy. Member of the Apache Software Foundation. I am not a committer on this project. But I am a contributor, and actually I was a little shocked to find out how long I've been a contributor, since apparently July 07. So Solar 284, a 3-digit JIRA issue number, I'm very proud to say was my first JIRA issue for the Solar project. I got into Solar thanks to Eric Hatcher, who many of you might have met. He's the one who fed me the Kool-Aid on search. And this was a project where we had to extract rich content from documents and store it in Solar. So I submitted the update rich documents request handler, and that eventually, different code base, but eventually became Solar Cell and Tika projects. I did not have a direct path between those two. The one thing I will say is, we're all obviously Solar users, so we're familiar with open source. I always point to this issue as a great example of how open source works. This patch to Solar was taken by 3 other companies, 3 other people, 3 other companies, and they each took the patch, extended it, fixed it, made it better, and contributed it back. So if you go back and look at 284 and look at the history over time, it finally got closed in Solar 1.4 bulk close when Tika and Solar Cell came out. But it was a great example of open source contributing back and getting back a better product. So, if you're thinking about, hey, I've done this really cool thing, should I try and contribute it back to Solar? Hell yeah, definitely. So who knows where it'll end up. So one of the reasons I'm talking about testing is because I'm also fascinated by the art of software development. Why is software so hard? Why do we have the iron triangle of scope, time, and budget? And I like to talk a lot about testing because I think testing is one of the things that makes us better software developers and makes projects go better. In fact, I'm so obvious about it, I have an armband that says Test Obsessed. So testobsessed.com is a great website with a lot of great content about testing. So I am author or co-author of Solar Enterprise Search Server from Pact, and our 3.x version I'm very proud to say will come out before Solar 4 comes out. So in fact, it'll come out sometime in the next couple of weeks. Our publisher said, you're done. Quit messing with it. And I'm very big into agile software. That's my family Scrum board. Anyone else have a Scrum board at home? Excellent. I know. Scrum for did you read Scrum for Kids? That was the blog article and the guy who turned me on to having a Scrum board at home. So there's me on the left, my wife, and then our best friend who was living with us for a summer. And because we had 3 adults in the house, who was cooking, who was doing what, we had task cards, and you can see that behind us. So that's our family Scrum board. We have a daily stand-up right before going to work. So I get multiple stand-ups a day. I'm going to start out with the statement that testing is hard. Okay? Testing is not an easy thing. Despite the fact that testing always gets its budget compressed, it's the last thing we do, testing is hard. And, you know, I looked at this picture, and I'm thinking one of the things I really got out of the movie version, maybe even more so than the book version of The Lord of the Rings, was what a burden it was for Frodo to carry the ring. And it wasn't that he did anything. It wasn't that he was fighting all the time or carrying heavy pots and pans, right? Sam did all of that. What Frodo carried was responsibility. And I think that's one of the roles that those of us who are testing our applications, and hopefully all of us, regardless of whatever role we're in, are testing our work and testing our applications. It's a difficult thing. And a lot of it is because it's that responsibility. We're the ones who make an application work great, right? We're the ones who say we need to spend more time on this. The activity of testing is what often injects quality. Now, does testing create quality if it wasn't there to begin with? No, but testing definitely helps bring it up and put the polish on. So this is the Mars Climate Orbiter. Back in 1999, it was supposed to go in orbit around Mars, $125 million satellite or scientific mission. Unfortunately, it ran right into Mars instead. So yes, they should have called it something like Mars Climate Impact Device. What happened was Lockheed Martin, the builder of the satellite, was doing all their calculations on thrust using English foot-pounds. NASA, who was responsible for all the navigational data and all the navigational systems, were taking that thrust or velocity data in Newton's foot-pounds. Obviously, there's a mismatch. 1.4 was the modification that they needed to do. So the satellite, instead of going into orbit at 150 kilometers above Mars, tried to go into orbit 47 kilometers above Mars, and the atmosphere resistance caused it to get torn apart and crash. So a very, very expensive scientific mission that took years to put together and years to get there failed because two groups didn't test that the numbers that they were using matched up and didn't test their transformation algorithm. So here's a picture of Frodo looking much worse for the wear. I think this is from the third movie. And I feel like testing search engines is even harder than other types of testing, right? Testing a static application, pretty much once you know it works, it stays the same. But with search engines, they're constantly changing. The data is changing. What the users are looking for is changing. We have a tendency to constantly keep tweaking them, right? We like to call it relevancy tuning, and we look at it as a good thing. But it also means from a testing perspective, we're constantly messing with them. And then there's another reason why testing search engines is harder. I need 2 volunteers, and I'd love an American and a European. Come on, someone, don't be shy. This isn't anything crazy. There's nothing, no hypnotism. All right, come on up. I got a European. Well, no. Are you a European? I'm American. I know. That was my joke. Right there. Take a pen. And the rest of you can follow along. Hey, come on up. Why don't you tell us your name real quick?
I'm Tyler. Alexei.
All right, excellent. And I need you to answer this question for me. Right behind you. All right, go ahead and write it down. You know what the answer is. Now, how many of us have search engines where we're trying to answer these types of questions, right?
All right. I'm the American up here, right?
Yes, you are the American. So there's an obvious answer that you're supposed to give, which all of you already know what the point is that I'm trying to make. But all right, so why don't you go ahead and show yours?
Cowboys.
All right, Dallas Cowboys, about as American as you can get. And?
Chelsea.
Oh, wow. Yeah. Wow, you're a brave man to come up on deck. So right there, right? I'm writing a binary unit test. Assert answer equals, and what is it, right? I have to model up who my user is and a whole bunch of other things. Now, if we had a lot more time, I have a whole bunch. Thank you very much for your willing participation, gentlemen. And I'm sure all of you had different answers as well. So if I had more time, there's all sorts of slides on why search engine testing is hard, but this is a great example. So what are some things that we can do to make our search engines better, right? How do we start figuring out if it's the Cowboys or Chelsea? So stepping back, that's the poem from The Lord of the Rings that I remember reading as a kid, and I was thinking, hey, how about that as a metaphor? What are sort of 3 things that elves would do if they were testers? What are the 7 things that beefy dwarves would do? 9 things that men, people like you and I would do, and then how do we tie it together? So that's sort of the grouping for the various techniques that I did. It's really hard to find on Google Images a picture of an elf from The Lord of the Rings that does not look like a pinup poster. So I had to hunt around for a little while. So I think of elves, they're the long-lived ones, right? They've got the long view, they're looking at the big picture, maybe not getting down too far into the weeds. And so these are sort of 3 techniques that you might use if you were an elf around relevancy testing. Judgment lists, search logs, and user feedback. So now, none of these things I'm going in super depth into. There were some great presentations on judgment lists. But I do want to show what a real simple judgment list can look like. Now, is everybody familiar with a judgment list? Familiar with TREC, the Text Retrieval and Encoding Conference? So that was a conference that seemed really big up through the 90s. So what they did is it was a conference where people would test search engines against a corpus of data. Maybe it's medical data, maybe it's IRS forms, maybe it's books. And people would come up with what they called judgments, which was a long list of here is a query, and these are the responses that I would expect. And there's a whole schools of people doing smart things on, like, how does position impact my relevancy calculation? But at the heart of it, it's basically, as you can see in this screenshot of a Google document, it's just a query with a list of expected results. And I've found this to be incredibly useful when I'm working with a non-search person who I need information from on what is a relevant result, right? I can have a sort of very free-form and dynamic question with them, or conversation with them, which is good. But at the end of the day, I need something written down, something that I can test against. And so with this company, Novus, they sell antibodies, reagents, other things used in sort of big pharma type things. And I didn't want to have to become a biology major to understand their data set. I just wanted to write a search engine and return what they wanted. So I sat down with their marketing manager, who knew everything about this business, had been there for 10 years, and I asked him, well, what are your top 20 queries, or what are your top 20 queries that you're unhappy with? We were doing a MySQL to Solr migration. And so he listed out a bunch of queries, right? And you can see that very quickly, it was obvious that one of the things that he was concerned about was tokenizing of different product names. HIF space 1 space alpha and HIF-1 space alpha, right? All he needed was a word delimiter filter factory to be happy. But if I hadn't sat down and had him write down a list of queries and what were the difficult ones they were having, I wouldn't have known that. And so very quickly, it became obvious where to start focusing on. And then he gave me a long list of product IDs. Now, I don't really know what the antibody is, the NB100-105 is the product ID for, but I don't necessarily need to know at this level of sophistication. He's just giving me a long list. So what did we do with this judgment list? Well, we have a little tool that we call our query replay tool, and it's very simple. It just takes a list of queries, runs them against an endpoint, some sort of search engine, and collects some basic statistics about it, some basic data. So we call that judgment list was called the difficult queries list. It was a Google Doc, so it was online. He could add to it, tweak it, change it over time. It was a great collaboration tool. And you can see the queries on the left, and then there's the sort of the results for the difficult queries. And so we ran them against the difficult queries list, which obviously got perfect overlap because that's the source data. We also ran it against their original MySQL-based search. and collected a bunch of results. And then we had two, and in the screenshot, they're sort of confusingly named Ajax search and web Solr search. We just had two different Solr configurations with different boosting, different tokenizing. And we collected a whole bunch of data. And we kept running this over and over and collecting more data. And we could take that information, and this is a very, very simplistic way of measuring it, but we said, okay, what is the overlap between the original search and our difficult queries, the desired result? What was the overlap of Ajax search? And what was the overlap of web Solr search? And through some very basic math, we knew that we were working better. And we actually had two different people. I was the one working on the web Solr search approach, and my colleague was working on the Ajax search approach. And it was great, because we also had a little bit of a competition who was tweaking it and tuning it better. Turned out my approach was, I still think it was a great idea. It just didn't work very well. And so you can see, there is the improvement at the point where I collected this data. And we were also able, from iteration to iteration, because we were collecting the data over time, we could give you these average improvements over time as well and say, are we improving things? Or, ooh, what seemed like a good idea was a bad idea. So this was very, very light, very, very easy. If anyone went to Ivan's presentation, they do a whole lot more of this with MRR, mean average percent. There's a whole bunch of mathematical models that you can apply. But at a very simple level, doing overlap worked just fine. I will put the caveat that judgment lists, while a great idea, don't help you with answering the question of who has the best football team in the world, right? If Tyler was the person who was developing the judgment list, the answer would have been the Cowboys. Otherwise, it might have been Chelsea. So judgment lists are only as good as the people who are doing them, and hopefully they're very representative of your user sample, but they're a good place to start. Our marketing guy kind of maintained his own judgment list as well. There's a set of queries that he had problems with, and he would periodically run them and just collect some basic data, number of hits, whether it worked or not, and he did that over time. One thing that I learned from him was be fairly methodical. You collect your data in a fairly structured format so that you can do something with it. A lot of people, look, I've had the experience of collecting lots of data, and at the end of it, not really knowing what does it mean or what does it do and what's comparable, right? It's the over time rerunning the test or rerunning it that gets interesting. So search logs, I'm going to move a little faster. So search logs, everybody has search logs, a wealth of information about them, right? Everything that our users are telling us what they want from us. That's fantastic. Nobody else gets that kind of feedback from a user. So throw your logs in a database, logly.com, Solr or Pig, and query them. And you can get some really great stuff. So here we did a bunch of queries, and this was a very simple one. The search queries were getting logged into a SQL Server database table, and we did a bunch of queries and collected some data. And what was interesting is on this project, we found out that although the client thought everybody on the website was searching for sort of full text, rich text, what it turned out is everybody was searching for part numbers, and that we really needed to focus our efforts on dealing with part numbers. That, we had an okay search for just regular plain text, but what people really cared about were part numbers. And we also discovered that the original interface had sort of faceting built in, but it wasn't done well, and people weren't picking up on the fact that there was faceting. So we said, when we start doing testing, let's really dig in and look at the facet aspects of this application, because people are doing queries that look like facets. Once we give them that, that's going to be a really important thing. And that was the SQL query used to build those two tables, right? Mining your data logs doesn't have to be a big deal, right? It can be as simple as a grep statement or throwing it into a database table. I get a little intimidated by all the talk of Flume and Hadoop and everything like that. And I'm like, really? Someone's going to pay me to spend 2 months building log analysis? I hope so, but I don't think so. So it can be very, very simple and yet give you a lot of value. Another quick example, right? Looking for your no results. Everybody knows this, right? Look at the no result queries and see what's going on. And in this particular case, we noticed that we had a lot of natural language looking style queries, and yet our must match parameter was a little weird and a couple other things. So the great thing about this was it armed us to know where to start focusing while testing, right? We didn't need to test everything. We needed to test certain areas, and it was how do we handle really long queries? How do we handle part numbers? We could be intelligent about using our testing time the most effectively. And then lastly, user feedback, right? Because we're constantly tuning in production and changing things, our users are a great source of testing. This is hopefully testing of, is it good or better, not does it work or not. And here's an example of a project where we rolled out Solr over a previous commercial search engine, and the exit rate from the search page dropped dramatically. I actually thought there must be a bug in the software collecting the web page results, because there was no way it could be that dramatic, but it was. And we also discovered that round about so it went live on the 17th, another release went out on the night of the 26th, and our exit rate went up. And it was and we went back and said, well, what changed? Why did our exit rate start going up? You know, nothing else really changed from a business perspective. And we realized that we gotten a little fancier with our faceting and added too much complexity. How many people see this every day? I hate them. But they are one way of gathering a lot of really good feedback, is just to ask your users to take a survey, right? Other ways, you know, on your website, you can say, how did these search results look like? One of the things, though, that I really like is, can I intuit what's valuable and what's relevant, what were good query results and what weren't, by actions that the user does? And I don't just mean counting the number of click-throughs or page views, because that just might be a user like, oh, that's not what I wanted. If a user takes a search result and then emails it to somebody, hey, go back and look at that query. That was probably a really good query, and the results that came back were examples of really good results. So we got some dwarves, right? They're the hardcore infrastructure, making, you know, digging the mines of Moria and all of that, right? So what are some techniques that we can use as we try and deal with, you know, making Solr work well in a really big environment? So a couple of things. How many people have a segmented, divided up server farm like that? You know, 2 boxes for development, 2 boxes for integration, a bunch of boxes for production. You know, that's a very common scenario. So tell me how you test your indexing algorithm, you know, your new indexing algorithm that's going to take 3 days to run on 2 integration boxes quickly, right? You know, so I'm a big proponent of moving to an environment where all your servers, regardless of size and everything else, they're in a big pool, and you're using them for the right job. So in this particular little diagram, right, we're doing load testing. And so we need lots of boxes to generate load. We need lots of boxes to act as the servers. And so we've taken most of the boxes, including most of the development boxes, because we're probably not doing development hardcore at this point, and using them for load testing. And then we have 6 that are serving up on production. Maybe we have a couple of developers using a shared Solr instance, so we only have 1 development box. I hesitate to use the word cloud because it's such a buzzword, but it is awesome when you can repurpose resources to whatever you need, and it allows you to be a lot more aggressive in your testing. You don't have to worry about, oh, we can't do load testing right now because the user acceptance group is making queries over there and we don't want to give them slow performance, right? Let's just spin up some more capacity and build our different test environments. It's also really, from a tester's perspective, it's really good when you can repurpose the boxes and you don't have to go to a sysadmin group that's going to be pushing back or saying, okay, it's going to take us a week to do that. You know, you want to have an environment where you can take a box and say, okay, I'm adding you to the load balancer for production, or I'm taking you out of the load balancer for production and building a new test environment running just a couple of scripts. So I think I drank a little bit of the DevOps Kool-Aid as well. So indexing. Indexing, I love, I think it's a British phrase, cheap and cheerful type of stores and products, right? So in the US, I sort of think of Target, or as some people like to call it, Target, to make it sound fancier, as the cheap and cheerful store, right? Great products at a really great price tag. You don't want your indexing to be down at the Dollar Tree. The Dollar Tree in the US is a store that sells things for $1, and the stores are dirty. They never have products. It's an unpleasant shopping experience. I'm not suggesting that you want your indexing process to be cheap in the sense of it's constantly failing. I want it to be rock solid and work really well. But I also have seen that a lot of people, whether intentionally or not, their indexing processes and building an index is like launching the space shuttle, right? The space shuttle used to cost $500 million every time they lit it off, right? That's $500 million shooting out of the tailpipe of that thing in that picture, right? No wonder they weren't launching the shuttle every week like they were supposed to be. It was $500 million. So we want our indexing processes to be in the middle. And if our indexing processes are not in that sort of perfect middle, then it becomes very difficult to try out new indexing strategies, right? How does n-gramming work? Well, I don't know. Let's give it a try and start doing some real queries on things. You know, if indexing is a 3-day process that you can only do on the weekend, one of the things you'll get tempted to do is make more than one change to your indexing algorithm and processes just because you don't want to wait another week to rerun all the indexes. So then when things happen, you don't know whether it's because you changed schema.xml or you changed your auto commit rate, you know, what impacted the environment. So that ideal middle is where I like to be. Subsetting the data. I think there's a little bit of a fetish with Hadoop that I should throw all my data together and I can't do anything if I don't have all 250 million documents. I had this experience on a project recently where we did not do relevancy tuning at all until the end because all they cared about was the number of documents in the index, right? And I'm like, there's 150 million in there. We can't start doing some real queries. We have to wait till 250 million. You know, let's grab a reasonable subset. Let's be intelligent and think, what does a reasonable subset of the data look like? And then this little script here I just threw here, I love the new CSV support in Solar. You know, here's a script where we are grabbing 500,000 records off of a big Solar running on Amazon and sticking it into my local Solar and rerunning all the tokenizers and indexers. And it was dirt simple to do it. It's, you know, 2 commands. I actually tried to get pipes working so that my wget command, which pulling the data out, would write to a pipe, and the curl command would read from that pipe and post it back up to my local Solar. That didn't work, but you know, writing out to a temp file, reading it back in worked out really well. So definitely look at the CSV handler as a really easy way of moving lots of data around your Solar, and you know, you get to use all the goodness of Solar to figure out what's the subset of data that you want to start playing with or modifying. Obviously, all your source data has to be stored in the source Solar. So in terms of scaling, so I put horse racing and metrics. I find that configuration changes are playing with configurations. Your solar.xml, schema.xml settings is more like play than work. I don't actually really know what's going to happen when I start changing things. People ask, well, should we be doing n-gramming on part numbers? Well, it's going to make it bigger. It's going to have these impacts. But you know what? The best test is to try it and see what happens, right? Hopefully, I'm using a subset of my data, not everything, but let me go try it. What is the impact of changing auto commit from 5 minutes to every minute, right? Are we going to start seeing weird garbage collection issues? If you're working in an environment where you have multiple slaves, one of the great things about having multiple slaves is, well, let's just roll those changes out on one slave, right? And see what happens. If I've sharded my data set over a whole bunch of shards and I'm playing with other settings, let's just change that one shard and see what happens, okay? And then compare it against everything else. Now, that only works if you've got good metrics, right? If you know that on average, every day, my average queue time is this, or you know, these are the number of queries below one second, these are between 1 and 2, between 2 and 4, and all of that. You need to have the scripts that are collecting that data out of your log files so that at the end of the day, you can actually compare, right? A point-in-time comparison doesn't actually inform you. There's too much noise in the system. So when I'm playing with configuration changes, I like to make one change and see what the impact is. And then JConsole and JVM, right? JVM tuning, I feel, is, to me, is very much a black art. And nobody ever, I'm typically doing JVM tuning because there's a problem. Production is going down. Bad things are happening. So you always get a lot of stress. And you know, people are not happy when they're doing JVM tuning typically. So there's the set of parameters that we're using on one project. Shard has like 15 million documents in it. Can't remember how big physical they are. But you know, there's the set of settings that we're using. Is this the right set of JVM parameters? According to one guy, it is totally the right set of parameters for us to use. I'm a little bit more dubious, and I think it's for a searcher, for a slave serving up update requests, or for search requests, and I think it's the right settings maybe for the master, but not for a slave. So the point being, it's a black art, so what do? One of the things is I love the print GC details it throws into my log when garbage collection kicks off and what's going on. It writes it to sort of the system.out, and that gives me some metrics. We went to 3.4 recently on one project, and we started seeing a lot more full garbage collection happening with these same settings, and so we actually rolled back to 3.1. And it wasn't that we had angry users or anything else like that. It was, well, we're not using any of the features of 3.4. We don't know why we're getting more garbage collection. We're just going to go back to what we're stable with. So, everybody here familiar with JConsole? Okay. I would think in this audience there'd be a lot of JConsole users. When I was a web app developer, I never even saw JConsole. JConsole, though, I'm more and more impressed with it for something that's just right out of the box. Does a great job of showing you the behavior of Solar. And I like to run JConsole all the time and just kind of see what my Solar, what's a typical behavior pattern. With that set of GC or JVM parameters, one of the things that we learned is that our Solar was great up to a certain load performance. It would just do these nice sort of jaggies of partial collection and everything was good. But if we hammered it a little too hard, there was a tipping point where it was getting more requests than it could handle, and it just kept consuming memory until it sort of ran to the limit of the RAM it could use. Full garbage collection would happen, stop the world event, and typically the Solar server would kind of keel over. We were able to kind of learn that by watching a visual representation versus just straight up looking at log files. So if you've got two sets of JVM parameters, fire up 2 copies of this. And a tip is that through the command line interface, you can start JConsole up, and it'll automatically, you can pass in the connection parameters. So it'll start however many you need. Everybody familiar with Solar Meter? All right. If you're not familiar with it, run, don't walk to go play with it. It is an awesome tool it is a load testing tool that isn't generic, it's meant for Solar. Unlike maybe some other load testing scenarios, in the Solar world, we're typically interested in 2 behaviors, indexing and querying, right? And they kind of happen at the same time. And that's pretty much all we're really interested in, is those 2 big behaviors, along with the occasional, what does an optimize do to my environment. So I'm going to go ahead and just real quickly, hopefully my local environment, everything is playing nice. So right now, I am running a whole bunch of queries on my Solar. So out of the box, Solar Meter comes pre-configured with the queries that work with the example Solar schema. So if you're kind of wondering, what's the impact of merge factor, right? Why is merge factor of 10 the right one to use? What happens if I make it 100 or 1,000? Well, you can very quickly start, download Solar, run the example app, point Solar Meter at it, and very quickly get a sense of what's going on. It's got some nice little charts and metrics. What's the average query time over time? How long are commits? If I trigger a Optima, I'm missing the right-hand corner, but different events, how long do they take? And probably more interesting, there's all my queries being listed. Errors, fortunately don't have any. So it'll also start showing, the timeline is all cramped because I've been running it for an hour, but you can see I start getting data points. But Solar Meter hooks right into all the caches for Solar. So you start getting a sense of what is my cache hit rate. And it's not just going to the statistics page and getting the exact explicit point in time. It's what's happening all the time. And I don't have to be running queries to get this information, right? I can just point Solar Meter at a production Solar. Don't start up the query console, and it'll be just looking at those caches and pulling that data back. So really great way to start visualizing what's going on in your Solar. Go ahead and stop. So, and then lastly, as much as I like Solar Meter with its GUI and everything else, it's not always the right tool. I'm also a big fan of using Apache Bench and curl to put a whole bunch of load on your solar and see what's going on. So that's the blog post that I read a couple of years ago about using Apache Bench to test solar. I've done a little bit of playing, like does solar work better in Jetty versus Tomcat? Honestly, it was kind of inconclusive data. But, just what's the sheer number of requests that I can pass in? And then just in this little picture is a little script that is firing up Apache Bench at different levels of concurrency and number of requests and dumping that data out to a log file that gives you a nice pretty curve. So if you look at this, I'll have the link to the slides will be on the very last slide, the bit.ly link, and you can go find this blog post. Really well-written blog post about using Apache Bench to measure the effects of RAM and memory on solar. Somewhat simplistic because Apache Bench can only call one URL. So you're not really representing user load, but it still gives you a data point. So what are the sort of developer techniques? And I'm going to run through them because I want to leave some time. Obviously, unit testing. Everybody here write unit tests for all their Java code and other things? If you're not, you really should be, right? So unit testing, great first place to start. My next favorite thing, and this is pretty new to me, is Cucumber. Anyone familiar with behavior-driven development? Yeah, excellent, excellent. I think behavior-driven development was one of those things that was promised 3 years ago and only now is starting to be usable. But how many people have had to write a search engine where you had to simulate another search engine syntax, right? We're doing a project where it's where we are replacing a search engine called BRS. I'd never heard of it before, but it has a specific syntax. And the people who use it want to continue using that syntax. So with behavior-driven development, what you write is called a scenario. And it is a human readable, right? Everybody understands more or less what's going on in here. It's a English human readable novella or little story, right? And it says, when given I am on the website, when I pick a BRS search type, and I search for apple and banana in parens .clm. I have no idea what .clm means, but it's part of their syntax. Then I get results, right? And so let me go ahead and show this run. Not going to show it running because the website we were going to is not online, or I don't have internet. So I'm going to run my script called cucumber search syntax.feature. Pardon, my Ruby is a little unhappy, so it's throwing out a bunch of erroneous error messages. What's happening right now is it's reading that script and firing up Firefox and connecting to the website. Hopefully the internet works, right? And this is just a real simple website using Blacklight. Anyone's used Blacklight? It's a great way of quickly making a website. And you can't see it, but the select, oh, there, it shows BRS. And I'm not doing anything, right? This isn't, there's no one else running it. It's a script that is driving Firefox and telling it to do certain things. And then I did another script, which was, I want to search for apple and banana in title. So there's my two test cases, right? And so what happens is you could sit down with the business and say, all right, what is this BRS syntax that you mean? Oh, this says apple and banana are searching the claim text field that, according to rules, gets shortened to .clm, right? And okay, this is what, we want to do unstemmed search. All right, does that mean unstemmed everything? What if there's a number in the middle of the word, or all of that, right? You can sit down with the business and write with your business analyst, or potentially they can write it themselves, this type of script. Now you may think back to, well, what about the judgment list, right? Judgment lists are great for, here's a query, here's a set of responses. But as soon as you start saying, I want to make specific choices, I want to click on a facet, and then I want to see more like this, there's too many steps, too much complexity going on there to work in sort of the traditional judgment list typically. So this works very well to sort of write a novel that both the business and you can use. And the code to support this, you get to separate creating the story, creating the scenario from the code. So here's the code that drove that browser. I started up a browser. I said, go to a website. I said, when certain patterns match, do certain activities, and then do some basic validation. So you can have your test engineers or your developers write the code while your business writes a story. So that's Cucumber, and cukes.info has more information. I'm really excited about the potential of really nailing down my business analyst and customer and saying, what do you mean when you say you want to search for that? And getting rid of all that gray area that is often there. Now, real quickly, Robin, do you want, I'm so glad I came to this conference because I got to meet Robin.
So RDD stands for Relevancy Driven Development, and it's a bit of a hobby project that I've been trying to fit some time into. So it ties very neatly into what Eric's just presented on Cucumber. So I came across behavior driven development through EasyB about 3.5 years ago, and recently on some of my solo projects I've been doing automated testing, but on the performance side. So using the access logs, replaying them through JMeter, tracking it in a continuous integration server. So I had a set of trends, but it still wasn't answering some of the relevancy questions. So in a story fashion, so this was sort of an actual EasyB example. So you've got, again, the scenario, given a sort of data set, when I do a query with a sort order, then I get a set of results. So the idea is that it work with a constrained data set. So if you used to use DB unit, you sort of understand the principle, control what the boundaries are, and then in this case, you know, we've got a set of product IDs. They know the product IDs. It sort of ties into the judgment list approach, but yeah, it's a work in progress project at the moment. So you know, you can sort of watch it on GitHub or sort of follow me on Twitter, and as it moves on, then you know, we'll see where we get to.
Excellent, thanks. So yeah, I'm excited about the idea that there may be a way of writing tests that are working at more the direct Solar layer and making it easy to crank out a bunch of validation tests. So a couple other things. So continuous integration. Big fan of continuous integration. Not a big fan of that approach to continuous integration, right? So continuous integration, we want to be running these tests like the Cucumber tests or relevancy-driven development or whatever it is. We want to be running them, and if you break the build, that's okay. It's not okay to go home for the weekend, but it is okay to break the build as long as you fix it. So, close to wrapping up. Want to highlight something that I'm not sure if it has a future in Solar, but how many people have played with SOLRITAS, the built-in velocity browse interface? Okay, great. So it's great for doing a very, very simple Solar interface that isn't XML. And I got a little hobby project. I'm trying to build a better Spotlight for the Mac than Spotlight using Solar. And so I've indexed a whole bunch of documents, emails, and I am going to search for Melia because I sent some emails. Now, one of the things that I like about a very low, what designers like to call a low fidelity interface, is it's very simple. We're not getting hung up on the colors or anything else. We're focusing on, hey, are those the right facets? Path search, content type, meta content. What are my, I've got some basic range buckets that I put in, some pivot facets. Something I really like, you can get clustering using the Caret2 library, right? So you can see I had emails about the Tuesday night reception with Carl Wright about our manifold panel and something else along Tuesday morning. So you can see that Tuesday was a busy day for me. And built into this is something that enables you to see some debugging. So what was my Melia query? Oh, that's what my Melia query looked like, right? I didn't have to go in and look at JSON and XML, and I can expose this to a somewhat savvy business user, right? And they can be like, oh, I tried this query and this is what it got turned into, and I can look at that and say, oh, we need to do something different with our boosting factors. Or, why did I get a result? I'm working on a project where people say, this word is not in the document that you returned. Well, it is. It's just it's in a comment field inside of an HTML email, and that's why when it renders, you don't see it. So I love that the explain feature is exposed right here. You can see why this document was hit. I'm especially excited that in Solar 3.4, I guess as well, explain is in a structured format where we could start building into our search applications. Why did this document come back? What did it hit on? Tell me why I got this result. So SOLRITAS, I don't know if it's going to be in the core or a contrib module. I find it fantastic for building a very quick, easy search interface. Would not use it for anything complex. And it lets me start playing with my real data set, right? I like using a real data. Mock objects, if you're hung up because you're like, I need 100 million documents before I can test this, I would say you just need to mock up what you're doing, and that will lead to better, more testable code. And then lastly, one of the things I struggle with is every time I test the search engine, I test it thinking Eric Pugh, search guy. I know exactly what to do. I know how to do a Lucene query. I know how to make sure I don't accidentally break the Lucene syntax parser when I'm typing it in. But that's not who my users are. That's not how they test the search engine. So when you start looking at features and how are people working with it, I like to develop a couple of personas. Now, this was for a company called Baby Center. Anyone had a kid in the last couple of years? You or your wife definitely use babycenter.com, or so they have. We had to get out of our head and into Baby Center's head. What does a stay-at-home mom do, or who are the various people? And so we develop personas, and they give us a way of looking at things and thinking, really, would I do a star in a query? Depending on who it is, maybe I would, maybe I wouldn't. But it lets me start being more intelligent about my testing. And we like to think of scenarios, right? What are the typical use cases? So on Baby Center, the scenario that we experienced, Baby Center has two major users. One that are social and there to kind of browse and collect content and connect with other people. And then the other people are parents with their first kid it's 3 in the morning and their child has a fever and they don't know whether to call, go to the emergency room, or can I just give Tylenol and go back to bed, right? I need an answer now. The child is screaming. Is 102 too high, or can I give it Tylenol? 104, what happens? So they're looking for a very specific answer. They don't want chatter. They want the answer, not 10 answers, and they want the answer to be certified by the medical board that Baby Center has. So they want a lot of boost on validated, authored articles, right? Developing scenarios and personas gives you a chance to kind of think through, how do I interact with my search engine? Gets me out of my head. So how do we wrap this up? And I'm a minute over. The biggest thing I would say is repetition, right? All these techniques, if you only do them once, are only going to give you one data point, a momentary potential improvement, or just highlight you have a problem. You need to pick the processes that work for you on your application and repeat them over and over and over. The more times you do repetition, the better your product will be. And the investment, whether you're building Cucumber scripts or manual tests or whatever, the more you run them, the less expensive they are. So repetition is my big thing. And I'm very big on when we're testing, sure, we can test the individual aspects or the parts of the search engine stack or the search stack, but make sure you're testing across it, because it's the user interface talking to the search engine, talking to the data is where you'll have problems, right? Solar may be blindingly fast, but if it's always returning 0 results because the UI doesn't facilitate asking a good question, then you have a problem. So very big on looking through all 3 layers of the stack when testing. And then lastly, in the testing world, there's always a lot of debate. Should everything be automated? Cucumber tests are the only way to go, or relevancy-driven development. Or do we hire a bunch of Indians in India and they just sit on it and hammer out a bunch of queries, right? I think it's a balancing. It's a seesaw, not one side or the other. And I think we as humans are very good at testing, and it's what we do. This is a picture of an Apple store. And one of the great things, one of the reasons Apple has done so well with the Apple Store is because people come in and they call it playing, I call it testing iPhones and iPods and Macs and everything else, right? Testing is something we do every day. Just navigating my way here to the hotel for the conference, that was a test. So we do it every day. And if you're interested more in testing as a human activity, James Bach writes a lot about it. So thank you very much. There's the wrapping it up. So.